Okay, let's start with the introduction of adipic acid. So, what is adipic acid? So, adipic acid is an organic compound which has a chemical formula of CH2,4COOH2. Other than that, it is also a colorless, odorless, crystalline white powder that is insoluble in water but very soluble in a hydroxyl group such as ethanol and methanol. And besides that, adipic acid is produced industrially with the oxidation of cyclohexanol and cyclohexanol with the presence of nitric acid, which the United States produce around 810,000 metric tons per year. Okay, so what are the uses of adipic acid? Almost 90% of the adipic acid produced is used in the production of nylon. So nylon is a protein-like structure that is further processed into fibers for application in carpenting, automobile tire cord, and clothing. So these are another example of production of nylon, which are safety belts, parachutes, and ropes. So all of these three products have one common characteristic, which they are very strong, which makes them very hard to break. And besides that, adipic acid is also used to manufacture lubricant components and plasticizers. From an industrial perspective, adipic acid is the most important decarboxylic acid because about 2.5 billion kilograms of this white crystalline powder are produced annually, which mainly as precursor of the production of nylon. So the price of adipic acid per kilogram is about 1.6 to 1.9 US dollars, and the largest production of adipic acid is produced within the North American region. This is due to its high demand from the engineering, plastics, and textile industry. So adipic acid is majorly produced in countries such as China, America, Japan, and Germany. So currently in Malaysia, we do not produce or manufacture any adipic acid. We only become the supplier from the local countries.
It is well known that the production of adipic acid can be done through the catalytic oxidation of Ka oil. This is the route that can lead to the production of adipic acid. For this discussion, the Ka oil can be produced from the cobalt catalyzed oxidation of cyclohexane, as we can see from the picture. Okay, so now let us move on to the reaction mechanism of this production of adipic acid. And during this discussion, the selected manufacturing process of adipic acid will be the catalytic reaction of cyclohexane and also cyclohexanol, where these two mixtures also been called and known as Ka oil, ketone alcohol oil. Okay, however, as being mentioned before, in order for the Ka oil to be reacted, the Ka oil first must be produced. So how we should produce this Ka oil? There are plenty methods of producing this Ka oil, and the most common is cobalt catalyzed oxidation of cyclohexane with air. So therefore, the first mechanism is the adipic acid production is the catalytic oxidation of cyclohexane. That is the first reaction. Okay, by referring to the picture, we can see that cyclohexane will be reacted with cobalt, which is the catalyst for the reaction, with air to produce Ka oil, which is the cyclohexanol and cyclohexanol. Okay, next is the second step of the process, which involves the oxidation of Ka oil with an excess of nitric acid in the presence of copper-2 and ammonium metavanadate, which both of them act as the catalyst under certain process conditions. Okay, so you can see from the picture, so this Ka oil will be reacted with all those catalysts and also the substrate in order to produce adipic acid. Okay, for this catalytic reaction of Ka oil, actually these two molecular reactions are believed to be happen, which are the cyclohexanol likely react with nitric acid to form reactive HNOX species, suggesting that cyclohexanol is an essential co-substrate with the pure cyclohexanol will react as the inert under the same conditions. Okay, so cyclohexanol act as the co-substrate while cyclohexane as an inert. This is due to the fact that the reactions for cyclohexanol is faster compared to the cyclohexane, which easily converts to cyclohexanol even at low temperatures, and proceed at a slower rate for cyclohexanol. That is why the reason. The selectivity of Ka oil mixture also actually depend on the complex activity of the nitric acid, which has acidifying, nitrating, nitrosating and oxidizing effects. And as we can see from the byproduct, this is due to the dependent variables.
Assalamualaikum, my name is Samad Shamil bin Mohammed Zain and I will present about the process flow diagram of the adipic acid.
First of all, this is the overview of the process flow diagram.
This is the PFD for the production of adipic acid.
Now, let's proceed to the process description.
Firstly, there are two steps required for the production of adipic acid. So the first process used is the oxidation of the cyclohexene. The raw material for the process is the cyclohexene, and the catalyst used is the cobalt catalyst. So the next step for the production of adipic acid is the oxidation of nitric acid process. Basically, this process uses nitric acid as a raw material, and the catalyst used to speed up the reaction is copper ammonium metavanadate. So this process produces yield for about 90 to 96%. Now I'm going to explain about the whole process for the production of adipic acid. Like I said earlier, the first step is the oxidation of cyclohexene. So the cyclohexene from the storage tank will be pumped into the mixer with the unreacted cyclohexene from the distillation column. And at the same time, the air from the atmosphere will be compressed and it will be enter the mixer. So the mixing process will be occur among the air and cyclohexene. So the mixture of air and cyclohexene will be enter the oxidation reactor, and the reaction will occur at the temperature of 165 Celsius and the pressure of 1.3 megapascal. The reaction of cyclohexene and air in the reactor will produce cyclohexanol, or can be called as ketone alcohol or Ka oil. Now, ketone alcohol from the reactor will be fed into the separator, where nitrogen dioxide and water will be removed as a byproduct. The resulting ketone alcohol will be introduced into the distillation column, where it will be distilled in order to improve the quality before it being sent to the nitric acid oxidation stage. Also, the ketone alcohol need to be distilled in order to recover the unreacted cyclohexene, and then it will be sent to the reactor feed. Let's proceed to the second step, which is the oxidation of nitric acid. So nitric acid as a raw material will be pumped and mixed with the ketone alcohol from the distillation column, and the mixture of ketone alcohol and nitric acid will be fed into the reactor where the oxidation process occurs. So the oxidation process occurs at the temperature of 70 Celsius and the pressure of 1 megapascal. So upon the reaction, the nitric acid is reduced into the nitrogen oxide, such as nitrogen dioxide, nitrous oxide, and nitrogen. The dissolved oxide will be stripped from the reaction product by using the air in the bleaching column and subsequently recovered as a nitric acid in the absorption tower. Pressed gas from the bleaching column now will be introduced into the absorption tower, where the off gas will be removed as a byproduct into the atmosphere. Furthermore, the adipic acid is required to be cooled in the cooler before it was sent to a series of crystallizer vessels. So there are three types of crystallizer, which are crude crystallizer, purge crystallizer, and refined crystallizer. So as an example, the adipic acid will flow through a series of crystallizer, which are crude crystallizer and purge crystallizer, as well as the filter, in order to remove the contaminant before being sent to the distillation column. So in the distillation column, the particulates such as cyclohexanil and adipaldehydic acid will be removed as a particulate, and the unreacted nitric acid will be recovered or recycled back to the nitric acid stream. Next, the adipic acid from the distillation column will be fed into the refined crystallizer, where a crystal of adipic acid is formed, and it needs to be cooled first from 20 Celsius to 5 Celsius, and the adipic acid which crystallized out need to be filtered before it being sent to the drying column. In the drying column, pure concentration of adipic acid is produced as a main product, while the water is removed as a byproduct.
Basically, this slide is the explanation that I already explained in the PFD.
Assalamualaikum and selamat sejahtera. My name is Omar Reza bin Abdul Manaf. Now I will proceed with the catalyst involved in the production of adipic acid. As you know, there are two ways to produce the adipic acid, which are the oxidation of cyclohexane with air to produce Ka oil, and the second process is the oxidation of Ka oil with nitric acid. Now I will start with the first process. The first process is the most common way to produce the Ka oil is being cobalt catalyzed oxidation of benzene-derived cyclohexane with air. The main role of the cobalt catalyst is to accelerate the oxidation by decomposition of the intermediate hydroperoxide, thus leading to the formation of alkoxyl and peroxy radicals. Therefore, the termination step will occur instead of the propagation step. As for the second process, the catalyst used in the oxidation of Ka oil with an excess of nitric acid to produce adipic acid is copper-2 and ammonium metavanadate. The reason why this catalyst is used to improve the selectivity of adipic acid and the consumption of nitric acid and the production of unrecoverable nitrogen can be reduced.
Assalamualaikum and hello to everyone. My name is Muhammad Afiq and I will be talking about safety. For the hazard identification of adipic acids, the product is highly corrosive that can cause serious damage to any part of human body. Based on the SDS, the product is rated as category 1 on serious eye damage. For these statements, it means that it is classified as corrosive to the skin, and for human experience, to the eyes, it is not fully reversible within 21 days. For the effect and symptom for human health is that it is delayed and acute if humans get too much exposed with the acid. Besides that, too much of inhalation can cause shortness of breath, also a very bad headache. It also can cause eye irritation from the acid's effect. Last but not least, ingestion the product too much can cause nausea and also gastrointestinal irritation. Next is the first aid measure. If a person gets exposed from the acid via inhalation, try to loosen the clothing of the patient for better breathing and put it in a comfortable position. For the exposure of the acid through skin contact, wash the exposed skin with plenty of water and soap. If a person gets exposed from the acid through eye contact, rinse and flush the exposed eye gently with water for 15 to 20 minutes. If a person swallowing the acids, rinse their mouth thoroughly, immediately seek for medical treatment if possible. For safety measures, wear a proper PPE when handling the adipic acids, such as goggles, fire-resistant clothes, and gloves. Avoid in releasing the adipic acids to the environment as the product is highly corrosive that it can damage to the flora and fauna. Immediately seek to medical treatment if people exposed too much to the acids. For the waste management, dispose the content to the right place of waste disposal. For the handling and storage of the adipic acids, store the acids in a cool and dry location. One of the ways is installing a ventilation to the storage room of the container. Besides that, keep the product tightly sealed in the container so the product will not expose to the air and environment. Avoid the product from contact with incompatible materials or chemicals. It means that if the substance reacts with it, it can cause an imminent threat to health and safety through an explosion. Adipic acid is not compatible with oxidizing agents such as nitrates, chlorine, and fluorine.
Commercial methods for producing decarboxylated usually involving oxidizing estenes, cycloaliphatic ketones, and cycloaliphatic alcohols with nitric acid in the presence of a metal oxidation catalyst. So in the case of adipic acid, a specific feed materials such as cyclohexane, cyclohexanol, and cyclohexanone in a mixture with nitric acid are heated at about 40 to 140 degrees Celsius with the presence of a catalyst. So hence, the resultant oxidation reaction product contains some adipic acid together with small amount of carboxylic acid and other organic components. So in the process involving nitric acid oxidation of cyclohexanone and cyclohexanol, economically significant amounts of succinic acid and glutaric acid are formed as byproduct in a mixture with adipic acid. So after the major portion of the adipic acid is separated by filtration and crystallization, The aqueous filtrate byproduct stream contains some adipic acid together with succinic acid, glutaric acid, nitric acid, and a catalyst. So hence, usually these filtrates are treated as a waste stream. Because of environmental and economic consideration, there has been a continuing research effort to develop methods for recovering the valuables and usable organic and inorganic components of the said filtrate waste byproduct stream. So the separation and recovery process usually involve contacting the filtrate with alcohol and extracting with the water immiscible organic components to provide an organic phase containing the formed esters and to provide an aqueous phase containing the nitric acid and metal catalyst values. So each of these phases is fractionated to separate the mixture into much more useful components such as dimethyl succinic acid, dimethyl glutaric acid, and dimethyl adipic acid. One of the several problems associated with the production of esters of carboxylic components is the accumulation of residual bottom fractions, which results from the fractional distillation procedure for the recovery of refined diesters. So if the residual bottom fraction is recycled to the esterification step in the ester production and recovery process, the heavy organic components of the said residual bottom fraction will cause a fouling on the equipment employed in the process. Therefore, the residual bottom fractions will pass through a filtration unit and then enters a white film evaporation unit, which then it will recycle back to the esterification stage. The vapor condensate fraction is recovered from the white film evaporation unit, which then is recycled back to the esterification stage of the process. The residual heavy end fraction is removed from the system as a waste stream and is readily disposable by burning and the like.
Besides that, the next topic that need to be discussed is the environmental issue.
Introduction, the adipic acid is usually used as a raw material for the production of nylon. Basically, this industry has left a detrimental effect on the environment by letting out a huge amount of greenhouse gas such as nitrous oxide during the production of adipic acid. Let's discuss about the environmental effect for the production of adipic acid. As you know, the greenhouse gas is produced as a byproduct and it can be considered as a very bad for the environment as it is a chemically trace gas that contribute to the recent increase in the Earth's temperature. Next, the nitrous oxide can absorb the reflected infrared radiation and also have the ability to absorb heat and as well as thinning the ozone layer. But not least, the estimated impact of anthropogenic nitrous oxide is 6% increase in ozone depletion rate. For the environmental law, there are several rules and legislation that need to be followed as the production of adipic acid has released an uncontrolled amount of waste gas to the atmosphere. The first environmental law that need to be complied is Environmental Quality Act 1974. This act relating to the prevention, abatement, control of pollution, enhancement of the environment for purpose connected therewith. The company must carry out any prescribed activity, shall submit to a report to the Director General containing an assessment of the impact to the environment and the proposed measure to prevent, reduce or control adverse impact on the environment. So the next environmental law that need to be followed is Environmental Quality Regulation 1989. This regulation make provision for the application or transfer of license for prescribed premise of scheduled waste treatment and disposal facilities. The premise shall keep inventory of scheduled waste as provided for this regulation.
Okay, so now let's discuss about some interesting facts regarding this adipic acid product. And as you can see from the statistic for global market, the majority of 2.5 billion of adipic acid has been produced annually is used as a monomer for the production of nylon by a polycondensation reaction with hexamethylene diamine forming 6,6 nylon, and other applications include some polyurethanes, esters for adipic acid such as DOA, that is di-2-ethyl hexyl adipate, which are used as plasticizer for polyvinyl chloride, that is PVC resins. The bar chart represents the estimated production of adipic acid until the year of 2024 only for the USA global market. And this rapid growth of this project is due to the engineering polymers, especially, for example, nylon 66 has been mentioned, a widely used ingredient in advanced engineering products which are used in automobile, construction, footwear, furniture, and even electrical and electronics components. And the market is driven by the demand of lightweight and durable products in the automotive construction and also electronics industries. Okay, besides chemical and polymer industry, adipic acid also has been incorporated into control release tablets, which used to obtain a pH independent release for both weekly acid and weekly basic. And it has also been incorporated into polymeric coatings for hydrophilic monolithic systems, which to modulate the pH, resulting in zero order release of hydrophilic drugs. While in foods, small but significant amounts of adipic acid has been used to give that jelly texture, especially for example, we can see through strawberry jam as a flavoring and gelling aid, and it is used in some calcium carbonate antacids to make them tart.
Now I will talk about the sustainability of the process and the production of adipic acid. The major environmental concern in the production of adipic acid is the emission of greenhouse gas, which is the nitrous oxide gas, which contribute to the climate change. There are several ways to be implemented in order to create more sustainable production. First of all, the industries that produce adipic acid had to be implemented N2O abatement technology. There are two methods of doing it. Firstly, the catalytic dissociation of N2O to N2 and O2. Secondly, is using the N2O as a reactant. The next way is the additive phase for the synthesis of adipic acid. The method of doing it by substitute HONO3 with O2. Catalytic dissociation is the process to convert N2O into N2 and O2. This is the simplest method for the removal of N2O. There are few classes of catalysts that are suitable in this reaction, such as noble metal, pure or mixed metal oxide, and zeolite. Next is by using N2O as a reactant. By recovering N2O from the off gas in a pure form and use it again as an oxidizing agent makes the process more environmentally friendly. The innovative solution has been proposed by Valves from October 2009 has been commercially used. The N2O is used as an oxidizing agent in the synthesis of cyclododecanone and cyclododecatrane, which is the raw material for nylon. By replacing nitric acid with greener oxidizing agent, which is oxygen, in the second process in the production of adipic acid with the catalytic amount of cobalt and manganate acetate and using acetic acid as solvent. There is one industry that has been studying this process, which is industry Asahi. They employing the combination of manganate 2 acetate and cobalt 2 acetate as a catalyst and using pure oxygen at atmospheric pressure. They succeed in obtaining the complete conversion of cyclohexanone and 77% of selectivity to adipic acid.
In the conclusion, adipic acid is an organic compound with the chemical formula of CH2,4COOH2. It is an odorless, colorless, crystalline powder that is insoluble in water. The application of adipic acid is mainly to make nylon 66 that can later be made into car painting, lubricant, and clothing. For the reaction mechanism of adipic acids that undergo two steps of reaction, the first reaction is oxidation of cyclohexane with the air to produce Ka oil, and for the second reaction is oxidation of Ka oil with nitric acid. Both of the reactions use different catalysts. For the first reaction, the catalyst used is cobalt catalyst oxidation of benzene-derived cyclohexane with air, and for the second catalyst used in the second reaction is copper 2 and ammonium metavanadate. Before we end our session, let us all watch an interesting video about nylon that is produced from adipic acids.
Nylon, a thermoplastic, is one of the most important synthetic polymers. About 4 million tons per year is produced worldwide. Much of the nylon is made into fibres for ropes, clothing, and for reinforcing tyres. Nylon is made from two monomers. Adipic acid, more properly called hexane dioic acid, has a chain of 6 carbon atoms. Just concentrate on the ends of the chain. Hexamethylene diamine, more properly called 1,6-diaminohexane, also has a chain of 6 carbon atoms. Again, just concentrate on the ends of the chain. When the two monomers react together, a molecule of water is produced as each link is formed. These two monomers continue to link together to form long chains called nylon. The raw materials used to make the two monomers are cyclohexane and adiponitrile. These are both derived from crude oil. Cyclohexane is oxidized, first by air and then by nitric acid, to give adipic acid. Adiponitrile is hydrogenated to give hexamethylene diamine. The two monomers first react to form a salt. Heating the salt to drive out water produces nylon. On this site, cyclohexane arrives by pipeline and is stored here. It is first oxidized here and then further oxidized with nitric acid made from ammonia in this plant. The product is adipic acid. The hydrogenation of the adiponitrile to produce hexamethylene diamine takes place here, and the two monomers are mixed in this building. Polymerization is carried out in this plant, and nylon stored for delivery to customers. Cyclohexane is oxidized to form adipic acid in 2 stages, first with air and then nitric acid. This is what happens in these reactions. Adipic acid, one of the two monomers, is a white powder. Adiponitrile is reacted with hydrogen to give hexamethylene diamine, the second of the two monomers. The two monomers are mixed together and react to give nylon salt. This and all other processes are monitored and controlled remotely. Nylon is produced from nylon salt by driving out the water. These are the tops of the autoclaves in which the salt, at a pressure of 18 atmospheres, is heated to a temperature of 280 degrees Celsius. At this stage, additives and pigments are added, and the conditions can be changed to produce polymers with different properties. When the white nylon is produced, it's molten and is forced through holes to form laces of nylon. The laces are cooled in water and chopped into short lengths about 3 to 4 millimeters long, called granules. Nylon leaves the site in lorries as granules. The granules, which are thermoplastic, will be remelted and moulded or forced through fine holes to make nylon fibres.